two parts. First one is the simulation part. There we are using the Keil software, and second part where there we have the interfacing. You have to see the demo how to operate the Keil software. I will show you example. You have to follow and go through that example, okay, and try yourself. Okay, the software name is Keil MicroVision 5. I will show the demo. First, you have to download the microcontroller software from the Keil. Okay, the company name is Keil. This is the icon. This is the icon from the Keil. Keil is a developer, and the software name is MicroVision 5. You can use any version of the MicroVision. Okay, the first step is what? Double click on this icon. Okay, after double click you will get this window. Okay, this is the window. Here you can see the file, edit, view, project, flash, debug, peripherals. Okay, and here you can see translate, build all. Okay, this is the target. Okay, so different icons you can see on the window of the Keil. Okay, I will show the steps. First step, go to the project. Okay, click on the new MicroVision project. Okay, go to the C folder. Here you can see the C folder in the blue line. Click on the C folder. There you can see the Keil 5 folder. Okay, here double click. Okay, here you have to create a folder. Okay, go to the new. Okay, go to the new and click on the folder and give the folder name. Give the folder name. So it is a 5th sem. Give the 5th sem B section. You can give any folder name there. Okay, double click on this folder. Okay, here you have to give the project name. Okay, the project name you can give anything, any name. File name. You can give anything. Here I will give my name, PANKAJ. This is the project. Okay, the extensions are here. You can see PANKAJ is a file name under the project file. Okay, save. Click on save. A window will be opened. As we know, we have to use the ATML series of the microcontroller for our lab. According to our syllabus, we are using the ATML. Here, these are the names of the different companies. Those manufacture the microcontrollers. Okay, for according to our syllabus, we have to go for the ATML. Already we discussed about the ATML. Here you can see this ATML. Click on the plus sign, and in the plus sign, which microcontroller we have to select? The microcontroller is a AT. Okay, please note down AT89C51. That microcontroller you have to select here. Go through this list. Here you can find AT89C51 here. Okay, click on AT89C51. Is clear? Then OK. Click on OK. Then a icon will be opened. Start.A5. Here click no. Okay, so this is the creation of the. Here you can see the project named PANKAJ. Okay, so this is the first step. Then go for the, again go to the project. Okay, go to the project, then go for here option for target. Okay, so AT89C51 microcontroller operates on 11.0592. Okay, already I have discussed in the theory class. It requires 11.0592 megahertz. Okay, so that you have to write here XTL, that is in the megahertz. Then checkbox. Here you can see the use on chip ROM. There you have to make it check. Okay, click on this box. Okay, so on chip ROM you have to select. Okay, then go to the output. Here again you can see a checkbox. There click on the checkbox, create hex file. Okay, so these two steps are required. First one is a frequency selection, and second one is a creation of the hex file. Okay, then go to the OK. Okay, this is the first step we have completed. We have selected the microcontroller named ATML. Then the model number is AT89C51. Then next step, we have to write the code. To write the code, we have to go to this icon of the file. Click on the here file. Here you can see file, new file. Okay, a editor will be opened here. You can see a editor is open, text 1. So here you have to enter the code. Okay, already the code is here. I am going to copy and paste. This is the code. This code is to transfer the data from the direct address to the destination as a register. So here you can see there is no hash is present here, means it is a direct memory. Okay, the 50 is the internal memory, there we have the data. Okay, 50 is the internal memory, there we have the data. So that data have to be transferred to the register or not. Okay, again second data is present in 51 edge. That data present in a 51 location, internal memory. Okay, there are two types of memories. One is the internal memory and next another one is external memory. Internal memory is of 8 bit and external memory is of 16 bit. Okay, so this is the internal memory, it is a 8 bit. So 51 is a memory location. Okay, so 51 is a memory location. From that we are storing the data or moving the data to R1 register. Already we have discussed while discussing the register, we have the R0 to R7 8 registers and A and B. Okay, so this is the example which shows the transfer of data from memory location 51 to R1. Is it clear? So here you can see 1, 50, 51, 52, 53 and 54. These are the 5 internal memory locations. From that addresses. From that we are transferring the data to the register R0, R1, R2, R3 and R4. Okay, so ORG means starting memory location, 0 means 0 is a 0 location, that is first location. Then end of the code, why always RET, it is called as a return, RET. Okay, the end of the code you have to write RET. So this is a simple code to perform the operation. Okay, so now let us see. After entering the code, you have to save it. For that, go to the file, you have entered here code, then go to the file, you have to save. Okay, so save, go to the save icon, then here give the file name. I will give the file name as a P4. Okay, then it is a assembly language code, so you have to give the extension. Okay, please remember extension will be .a. Okay, so .a, because the code is assembly language, you are writing the code in assembly language, so the extension will be .a. If you are writing the code in a C, then you have to give the extension as a .c. Okay, so then save it. So P4 is a file name .a. Okay, remember .a. Okay, so that is the extension. So then save. After save, here you can see, okay, it will be displayed on the top of the screen, P4.a. Okay, okay, so this file is created. So this file we have to load to the target. Okay, go to the here target, you can see here target, go to the target. Okay, second one is source group, click right click. Okay, go to the source group, click right, then 1, 2, 3 add existing files. Okay, so these are the existing files. Go to the here, a icon will be opened, a window will be opened, there you have to type P4 P4.a or here you can check the ASM file. Here you can see P4.a. Okay, after selecting P4.a, go to the add, see here add and close, add and close. So here you can see a plus sign will be there. Go to the again the project, this is the project, this is the target, and here source group. In the source group we have added this code we have added to our project. Okay, the name you can see P4.a. Okay, the P4.a is added to our target. So click on P4.a and we have to check the errors. Okay, any errors are present, that errors we have to check by clicking here. You can see we have the first one, translate, and go for the second, build. Okay, so this build icon is required to check the errors. Any errors are present, that we have to check by clicking this second icon, build. Okay, so click on build. Here you can observe, okay, all the details are there. So the message you have to display, is 0 errors. Okay, 0 errors, 1 warning. 1 warning is okay, no problem, but error must be 0. The errors must be 0 here. It have to display 0 errors. If errors are present here, you have to again repeat the steps. Go to the program. Again you have to make the changes. It will show the line where the errors are present. That line you have to make the correction. Again go for the source group, you have to add, and again go to the build. So the same process you have to repeat again. Still you will get 0 errors. Okay, so this is the second step. Next, you have to run the code. To run the code, go to the debug. Okay, go to the debug. Now I am executing the code. Okay, how to execute or how to run? Go to the, here you can see, after the flash we have the debug. Okay, go to the debug. Here you can see the start and stop debug session. Click on here. Okay, evaluation mode. Okay, click on OK. Okay, you can see the window will be changed. Here you can see our code is here. Here register window will be opened. Here you can see R02, R7, all the 8 registers named R02, R7. If you want to see the data in register, then you have to check here. So R02, R7. Okay, then I already explained in the architecture we have the 2 registers. One is the A, that is accumulator, and second one is a B. Okay, you can see these 2 general purpose registers, A and B. Okay, so these are the 2. SP is a stack pointer. Okay, stack pointer, that I am going to discuss in the theory. Then this is the DPTR, that is a 16-bit. Already explained DPTR. Okay, that is a 16-bit register. Then here you can see the PSW, program status word. Okay, program status word. This is used to highlight the activities after any arithmetic operation. After any arithmetic operation, a carry is generated, a auxiliary carry is generated, the data is overflow. Okay, then any sign like positive number and negative number. So these are used to check these things from the PSW, program status word. Okay, this is also a 8-bit. Now let us see how to check. Go to the, so as this is the data 50. Okay, this is the 51. These are the internal memory. For that we have to go for the memory. Okay, memory address. Okay, we have to give the data. We have to load the data in a 50, 51, 52, 53, 54. So that data has to be transferred to the R0. So we have to give the data. How to give the data? Here you can see this is the icon called the memory window. There you can see memory 1, memory 2, memory 3, memory 4. Okay, click on any memory window you can select. I am selecting in memory 1. Okay, so go to the memory 1. Go to the memory 1. Here you can see a window will be displayed. Okay, here this is the internal memory. So D colon 0 small x. What is the data? Oh, sorry, what is the address? 50. So type 50. So the D colon 0 small x 50. So this is used to check give the data in the 50 memory location. So enter. Okay, so here you can see D colon 0 x 50. So the 50 memory locations are opened. So here double click on 00. This is the first location, means 50th location. This is the 50th location. Double click, you will get the blue colored. Then there you have to give the data. So I am give the data. Let us assume 11 11. Okay, again go to the second, that is 51 22. Okay, that is second data. Go to the this is a 50, this is 51, this is a 52. In the 52 memory location, the data is 33. Okay, then next location is again double click, you will get the next location 44. So 1 2 3 4. Go to the next again memory location. So data is 55. So you can see here, this is the 50, means this is the 50th location. This is a 50, this is a 51, this is a 52, 53, 54. 51, this is a 50. In 50 the data is 11. 50 is a memory location address. There we have the data called as 11. Okay, so like this you have to give the data in the internal memories. Okay, then go to the here you can see RST. We have to run the program. Now after providing the data, we have to run. How to run? Go to the RST 1 2 3. Okay, so please remember step 1 line, okay, click on step 1 line. Okay, here you can see a green line, click again. Here you can see the R0 is loaded with 11, R1 loaded with 22, R2 loaded with 33. Again, here again you can see the change in the program. Okay, then 54. Okay, so here you can see R0 is loaded with 11, R1 is loaded with 22, R2 is moved 33, R3 is 44, R3 sorry, then R4 is 55. So here you can see the movement is from 50 to R0. So 50 location we have the data 11. So this 11 from the address memory copied to the R0. Okay, so that is a simple code, the use of the internal memory and providing the data into the internal memory. Okay, if we don't have any internal, if we have the direct memory, sorry, immediate memory, then what I have to do? Instead of here, we have to give a hash. How to do? A hash you have to give, then that is called as the immediate. Okay, here what happening? 50 is directly moving to the R0. Are you getting the difference? If the hash is there before the 50, means it is not an address, but it is a immediate data. So the 50 directly moving to the R0. Okay, so at that time you have to check directly here in the R0. So here in this code for that first line, the R0 will be the 50H. So the data immediately moving to the R0. If there is no hash, means the data have to give in the into the internal memory. Okay, so that is a checking running of the code. Okay, if you let us assume if you want to move the data to the external memory is of 16 bit. Okay, remember external memory is a 16 bit. How to check? Go to the X, so capital X. Okay, then colon 0, then small x, go to the small x, I will repeat again, capital X, okay, then colon 0, okay, then small x. As it is a external memory is of 16 bit, so no doubt we have to use the 16 bit data like 4000. Okay, 4000 is the address. 4000 is the address. So the 4000, 5000, 6000, 4 digit. Okay. 3 zeros to triple F. Okay. So that is a range for the external memory. So external memory is a 7 triple F. So okay, the range is 000 to 7 triple F is a range. Okay, so in that range you have to use the address location for the external memory. So external memory, here you can see how to give the external memory. X, capital X, colon 0, small x, 4000. 4000 is the example I have selected here. Okay, then enter. Here you can see the external memory locations are opened. Here you have to give 4000 means this is a 40 next 0. Okay, so total it makes 16 bit. Okay, this is the 8 bit, this is the 16 bit. Sorry, this is the 8 bit, this is the another 8 bit. So total it makes 16 bit. Okay, so this is for the external memory. So these are the steps for the how to operate the Keil and how to use the MICROVision 5 software. Okay, any doubts you can clarify in a, you can ask me. Okay, anything. Okay, so next if you want to close and go for the next code, what you have to do? Go to the debug. Okay, then you have to stop it. Getting? If you want to go for the next code, what you have to do? After checking the error results, everything, if you want to go for the next code, what you have to do? Go to the debug. Okay, start and stop. Click on the start and stop. Means you have to stopping. Okay, again it will comes to the first window. Here you can change again. Okay, so I will show here. Here let us see the immediate address. I will make it fast. Okay, now what I have to do? Save it. Already it is. You have to remove the first one. Okay, here you give the, again we have made changes here. Here I am doing the hash, entering the hash. Let us see this example. This is the immediate data movement to the registers, and here instead of R0 let us take a accumulator. Okay, let us see the code. So this is the code. Okay, the same file name is there. What I will do, go to the source, then add existing files, then already the code is there, so add close. Okay, so it will be here. Then what I have to do, go for the build. There we are checking the errors, so it is 0 errors and 1 warning. Okay, then what I have to do, go to the debug, start and stop session. Okay, right, again the window will be opened. So here you can see, so the code I have changed. So 50 hash is the immediate data. Okay, so it means that the 50 have to move to the accumulator, and 51 have to move to the R1. Okay, so let us see the code. Again go to the here F11. Here you can observe the 50 directly loaded to the A accumulator. Okay, so this is the A accumulator. Then I will click next line. So line is moved. So 51, here you can see 51 have to move to the R1. So 51, you can see the R1 is loaded with 51. Next 52 have to loaded it to R2. So you can see here the 51 directly moved to the register R2. So like this you can see the R0, R1, R2, R3 and R4. Okay, so this is the direct immediate address, immediate data movement. Okay, so this is a simple example I have shown. And if the data is there, that is assume the external memory. So no doubt we require a DPTR 5000, means instead of the A, what I have to do here? So we have to use the DPTR. Why? Because it is a 16-bit. Okay, so 5000H move to the DPTR. Okay, so here you can see it is not possible. Again we have to go back to the code. Okay, so this is one of the example 5000. Okay, if we have the external memory, please remember external memory is of 16-bit, like 5000 I have taken. We have chosen the 5000. When we are using the 5000, no doubt we require the DPTR. DPTR is a 16-bit and 5000 also the 16-bit. Both the register must be same in size. This is the destination, this is the source. The source and destination must be of the same size. That is a point you have to remember. Okay, if the external memory we want to use, then go to the 5000 and you have to record the register which is the same of size. So that is the DPTR. Okay, so these are the steps for the simulation for the first one. Okay, so first part, all the code you have to do from this software called the MicroVision 5. Okay, you can download the MicroVision 5 from the Google and practice yourself. Okay, thank you.